Okay. Before designing the synchronous counter on Logism, I want to give some steps which I will follow to design my circuit. Here the step 1, create a state diagram. In state diagram I will start from 000, that my starting point. Then transitions, how the transition sequence will work, it is 000 0 1 0 1 0 0 0 1 0 0 1 1 0 0 0 0, and I repeat this sequence. State representation, each cycle in diagram represent a binary state and arrow show the transition triggered by the clock pulse. And my second step will, I will assign those binary values to the states. State 00 as encoded as 000, all the states encoded with their corresponding values of 0 and 1. And stage 3, I will implement the counter using flip-flops. Here in 3-bit flip-flops, in 3-bit counter I am using the 3 flip-flops. The reason behind is that each flip-flop represent the 1 bit. So in 4-bit counter I will use 4 flip-flops. In 5-bit counter I will use the 5 flip-flops, etc. In my case I am using 3 flip-flops. And stage 4, state logic for each flip-flops. Flip-flops, I am giving these flip-flops as D1, D2 and D3, and their stages, how those Q1, Q2 and Q3, their values will represent their corresponding flip-flops. I will explain them further in my when I will design. Now I will connect the outputs. Connect first flip-flop output with Q1, second flip-flop output will Q2, and third flip-flop output is Q3, right? And here those Q1, Q2 and Q3 are my corresponding outputs. So my last stage is clock signal and reset mechanism. I will ensure that clock signal is connected to all three flip-flops to synchronization. Implement as input. I reset the counter state to the 000 because it is necessary, it is my starting state. Today we are going to develop a 3-bit asynchronous counter. Well, so what is 3-bit synchronous counter? Before going to the topic, what is synchronous? A synchronous is giving a same clock to all the registers. So here we will call the flip-flop as a register because it is storing the 1-bit data. So we have 3 flip-flops. For these 3 flip-flops we have common signal, and these signals are clock given to the each clock. So the clock can be found under wiring. Under wiring we can see clock source, so the clock source can be given here. And then we have 3-bit synchronous counter. Why, quickly, what exactly is counter? Counter x nothing, just it is start the counter from 0 0 0 0 1 1 0 1 1 1 0 1 1. That is maximum. The minimum value is 0 0 0 and the maximum value is 1 1 1. So counting, each flip-flops have 3 pins. So the first pin is called reset pin. Here this pin is called restart pin. When we click this, when we clear it, it will clear all the data and become 0. Then next pin is called enable pin. When we press this enable, it will start, it will switch on the corresponding flip-flop. The next pin is called preset. The preset means, suppose for example if a given preset comes from the default value, so every flip-flop value comes from, it depends on the connections. So here we have given preset value as a counter for 111. So now I have JK flip-flops. For the 3-bit synchronous counter we're using JK flip-flops. Here first input is given to the both J and K, then the output is given to the second flip-flop, and the same output given to the AND gate, and the AND gate from output is also given to the this flip-flop. So this can be why we are using this. So that is some simple answer. We have to go through these things. So we from this diagram we will find it. So from that we first I'm going to for first I'm going to enable the signals. So once I enable the signal, whatever the value is go to, it enable all the flip-flops. So I have given 1. When I now I'm giving to the clock signal. So it you can find that 000, and still when I press, then it becomes 1 1. When I off, it becomes off, like 0. First stage represents 0 and the second stage represent 1 and 0. And here the 0 1 1 0. So you can say that the 1 0, next is 1 0 1 0, next is 1 1 0. You can say that here is 1 1 1 0. Next one is 1 1 1. So the next is 1 1 1. So here there is it is a corresponding, and MSB is equal to LSB. The first one was NAV. When I press clear, it becomes 0 0 0. When I give preset, first I disable it. When I press preset, it goes to the preset value 1 1. So this is a 3-bit asynchronous counter operate.